Hey, how you doing? Sean Tech here. Welcome back to the show. Someone I was talking to recently was like, How does a soldering iron work?" I mean, just a simple little question right there. And it actually prompted me to thought, like, there's a lot of people that use a soldering iron that, kind of understand the basics. Like, if you had to say, what does a soldering iron do? It heats up real hot, you know. But then it got me thinking about a couple of other things, and it got me thinking, like, yeah, maybe I'll just do a quick video on two soldering irons, which I happen to have in possession right now. I've got your kind of Bob's brand, very basic one. We're talking like simple basic is what it is. Am I recording here? Is that okay? I've had so many problems here. I actually have a new camera that I am recording on, and for a second the microphone wasn't working and the lights flickered on at some point. There's probably a ghost or something like that somewhere on the inside of this. I don't know, but and who knows? Okay. So who knows what did on there? Anyway, so I've got this Weller soldering iron that I'm pretty sure I bought from Home Depot for like 15 whole dollars. And I mean, like, when you look at this underneath the underneath there, I mean, like, this has a soldering iron tip, and it's got a nice shiny tip. That's actually your first sign that, like, the soldering iron is usable, is that the tip that gets really hot. And that's all really a soldering iron is. There is this long metal piece right here, and this whole thing is going to get pretty hot, but at the very tip, that's going to get really hot. That's like where a majority of the heat is going to try and go to with it. Now I've got this guy right here, and then I've got my more favored tool is this Hako soldering iron that I've probably used in, well, every other video I've probably done with it at this point here. So take a look at this guy here, and there is also a metal shaft that goes up to a tip, and you hold these, just like you would kind of like a pen. And ultimately, what you're really trying to do with the soldering iron is to heat up the thing that you are trying to solder enough so that solder melts at the tip of the thing that you are trying to heat up. All right. So, like, ultimately, you're using the tip of whatever the soldering iron is. You are using either one of is this appropriate? Of these two soldering iron tips. You heat these things up, and you're hoping that the heat is good enough that it transfers through from these tips that I've got on screen down to the thing that you actually want to solder up together. And in a nutshell, the bigger your soldering iron tip is, the more heat gets transferred to the thing you're trying to solder. Also, the more massive your part is you are trying to solder, the longer it takes to heat up. That's like your general rule of thumb when it comes to soldering irons. Now, I'm not for or against any kind of particular brand of soldering iron. I just happen to have two that are here. The one that I've got from Hako is kind of expensive. I mean, like, you're probably talking the whole setup right here is $250 for a professional grade bench technician level thing. This Home Depot, or it's a Weller brand thing, so it's made by Weller. This guy right here probably costs somewhere in the range of like 30 to 20, $30, something like that, with a little thing of solder. It's not bad for an introductory thing. There's one important thing you really want your soldering iron to do, and that's something that my Hako does do, and this Weller soldering iron does not do, and that's have the ability to turn on and off. Right? This is actually somewhat critical for a number of reasons. Allow me to kind of demonstrate with this here. So I've got a Weller soldering iron. If you notice on this thing, there is no, here, I'll show it to you. There is no switch or anything like that. You follow this wire, you follow this whole wire here, follow the whole thing, and you get to the plug. That's the switch for the whole thing. Right? So the only way that this thing turns on and off is by plugging it and unplugging it from a wall socket. All right. So I'm actually going to turn this guy on right now. I'm going to leave him underneath here. One of my first beefs with a Weller soldering iron like this is exactly kind of what I just said. It has no ability to turn itself on and off. You notice right now, it has lights on it, which actually, for several projects I've used this prior to owning my Hako system, those lights are actually somewhat handy to it. Now, this also has no ability. This is my second beef with this Weller tool. It has no ability to set the temperature. I believe, in particular, the temperature on the Weller thing, on my Weller soldering iron, is set by unscrewing the tips. So that little Phillips head, or flathead screw loosens up and eventually connects up to a different tip. That's a big thing you want your soldering iron to be able to do. You want your soldering iron to be able to switch tips easily. For instance, on my Hako system, if I want to switch to any one of the other number of tips that I happen to have in here, and I've got tips that, you know, are basically meant for like kind of old different shapes and sizes. I've got some tips that are bent, some tips that are really large, some tips that are pointed. I've got the one tip I actually did a video on fairly recently that actually is really flat and has a hole that's meant to kind of help with removing solder from things. But if I want to exchange any part of this tip here, I'll leave this guy underneath this right there. We'll wait for him to get him loose. I'll put a nice white background underneath here. So if I want to replace the tip for my Hako station, all that I really have to do is take this out. Normally speaking, you actually want to use a black silicone grabber thing, so that allows you to touch the metal part, and I just remove this tip just like this from here. These tips can cost anywhere between, I'd say like $20 to $100, depending on how nice a tip that I want. The one that I'm holding in my hand right now, I think costs somewhere around $26. Now that's still not the main reason why I wouldn't want to kind of use this guy here. Make sure I'm focused on the Weller system while it's heating up as we speak right here. So if I want to put this tip back into my Hako, I snap it back into place here. I reconnect it. I smell something. You smell something? No, you can't. You don't have sense around, you know, or whatever. Okay, yeah, there's no surround sound smell or anything like that. This guy is now in. Normally, I would want to use this kind of a tip associated with this and just kind of push this guy into this here. And ultimately now that's connected up to, I really do smell something that doesn't smell good. What is that? So, but either way though, this soldering iron actually has a little bit of a setting that I can actually set kind of back in this way here. Still waiting for the Weller tip to kind of turn on. So this little station that's back over here allows me to turn on and off the soldering iron, like kind of powered on, powered off. Right now it's kind of warming up to a preset temperature. And yeah, like an alarm clock, like an old school alarm clock, I can actually set the temperature on this thing to be what it is that I want to set it to. In this case right here, it's like 610 degrees Fahrenheit, right? But then it goes into this thing right here, which says SLP, sleep is what it says. Am I actually capturing any of this on? I need to get my recording studio software up. Sorry, I minimized it on there. Oh, there we go. Can you see me? Hi, right? So this little guy that's way back here, right? It says SLP. Is what it says right now. It says SLP because if I take this thing out of its cradle, so there's this little cradle that's way back over here. If I take it out of its cradle, it's on at this point. It's on. But if I put it back into its cradle, it's off at this point. So it has the ability to turn itself off when I put this thing down. And that smell that I smell right now is the Weller station, because this is the #1 reason why these soldering irons really kind of stink. It's a major safety hazard. Take a look at the paper this thing has been sitting on right now. It's you know, I got myself a problem with that. You know what that is? That's because this soldering iron right now, this Weller soldering iron, is up at temperature. Okay, so this soldering iron is hot at the moment, and if you lay this thing down in just the wrong way, and worse yet, just forget that it's there, you're going to have a possible fire hazard if this thing sets on paper or plastic or something like that. You don't want that. You don't want the big red truck peeing on your house. Okay, so the biggest and worst problem with these Weller stations is, I mean, one, you can't turn them off unless you unplug them. 2, you can't set the temperature. And 3, they don't come with a cradle. And I can hear people who have welders saying, well, where's that little triangle stand that you have that's somewhere with it? Yeah, that thing weighs like an ounce, and this thing weighs, a few pounds, all right? I lay this thing on it in just the wrong way, and it's like laying it down the wrong way on a paper clip. It falls over, is what it does. So that's a problem. It's a safety problem. But, I mean, you take a look at this paper, this got hot. This got hot actually pretty fast is what it did. So what we're going to do here is demonstrate now in front of you what soldering actually is. So when you first start with a soldering iron, kind of like what I have right now, if I were to take some solder wire, which is a metal with a little bit of a material on the inside of it called fluxing agent. And the fluxing agent, when activated, kind of cleans the surface of what it is you are trying to actually solder. So if I touch this to the tip of my Weller soldering iron, this should melt almost right away, right at the tip. You see that? See that? It doesn't coat it very well at all. That's because my tip is probably dirty. Right? It's probably just a little bit dirty. So what I'm going to do here, I'm going to try to brush it off with a little bit of some brass material, some kind of brass with it. It still kind of looks like it's a little bit dirty. It might also be incredibly hot right now, just because I cannot set the temperature on this thing at all. So this thing is very likely very, very hot. I'm going to use a little bit of some fluxing agent on another board. Now, fluxing agent is an important thing. If you're soldering, you pretty much got to have fluxing agent somewhere in your tool collection somewhere. Is that okay? Can you all see that okay? All right. So what fluxing agent is for me is this fluid substance that when I spread the fluid substance around, if I activate it, meaning like I apply heat from my soldering iron to this thing, check this out. I'm going to apply a little bit of some heat to this right there. It starts to melt. And it's actually right now, it's producing a lot of fumes that are actually coming up towards me is what it does. This actually melted really, really well, right? So what this does is this is actually cleaning the surface of my soldering iron tip, as well as cleaning the surface that I'm actually soldering to. So if I were to take another look at my Weller soldering iron tip at this point, that actually does look pretty good. And if I were to take this pad that I've got right here and just sort of, I'm going to apply, actually I'll tell you what, I'm going to apply a little bit more fluxing agent to this guy here. All right. And now what I'm going to do is both apply heat from the soldering iron as well as a whole bunch of solder, which is basically melting. If you were to look at what the solder is doing, I am melting this into a sort of a liquid metal amalgam is what this is. I'm going to zoom in a little bit closer so you can actually kind of see what this looks like with the soldering iron. So I'm going to remove the soldering iron real fast. So there's no heat being applied to this pad right now because I'm holding this up here, all right? And this is re-solidifying is what it's doing. So it's turning back into a solid. See that? Right? It's actually turned all the way back into a solid. If I were to kind of poke this stuff right now, this stuff is, that's in its solid form. I'm going to apply some heat from my soldering iron, and now this stuff, this is liquid metal, is what this is. I'm like running a pair of tweezers through this right now. This is completely liquid. Remove the heat from this here and watch it turn back into a solid again. Okay, now it's back to its solid form. Now it's not going anywhere to it, right? So this thing has very little temperature control on it. And for some solders, you need some temperature control. It depends on the size of the part. For something really big, like some 12 or 14 gauge wires that are inside your house that you want to connect together, or some speaker wires, something like that, this thing works fine. But if I want to solder something as small as like the little chip components that are on top of this guy here, that actually takes a little bit of some finagling around with a soldering iron of this caliber is what it does. I'm going to put this inside a little handle here to give you another little demonstration using a couple of parts that I happen to have handy. Really nervous about that thing because I actually don't have the stand, and that thing's probably pretty dang hot is what it is. All right, so let me pull out a couple of parts that I've got floating around here that I can actually solder up to these two boards. I'm going to pull two different sets of parts out. One of them is going to be a really, really large transistor, all right? One of these really big things that I'm holding in my hand right now, which I'll put kind of on screen right around here. So that pad that I've actually just soldered in place is actually meant to be for this part right here. I'll just kind of put it into place. It's meant to go for a very large power transistor along these lines. And this is just a test board, something that I designed a while back just to kind of play around with some of the parts that we've been donated with over the past couple of years. The other thing I'm going to get is a couple of chip resistors, and I've got a few of them right here that I know fit onto this board. These are 1206 chip resistors is what they are, meaning that these chip resistors are 120 thousandths of an inch, so 0.12 inches by 0.06 inches is what they are. 120 mils by 160 mils is their overall length and width, is what those parts happen to be, right? So now what I'm going to do is demonstrate how heat application works using both of these two soldering irons. I'm actually going to tin the pad of the other pad here with my other soldering iron, my Hakko station. So I'm going to apply a whole bunch of fluxing agent to that there, okay? I'm going to take my Hakko soldering iron, which is set to 610 degrees Fahrenheit, is what that is. Boy, that is getting hot. Even my stand is getting really hot. That's made out of ceramic. I'm going to have to take that thing out of here in just a little bit. Great demonstration, right? All right, so using the same lead-based solder that I've got, which melts at approximately 200 degrees Celsius, is what this will melt at. And you can see right now, I'm kind of spreading it around. I'm making sure that solder is kind of covering all the different parts of this guy right here. Okay, so now I've got my main pad all covered up. What I'm going to do next is I'm going to try and take that really big transistor and I'm going to try and solder it onto that exact pad location. I'm going to use a little bit more fluxing agent before I attach this guy. Fluxing agent kind of helps no matter what, right? So a little bit more fluxing agent. Now I'm going to plop this guy on top. Now, the really difficult nature of doing this is that the only way that I can actually get to this transistor here, this actual transistor, is by applying heat to this large padded area back here. You see this large area? And this is my soldering iron on the southeastern side. And I'm going to apply heat using it's wiggling around all over the place. Get over here. I'm applying heat as well as some force and pressure. I am trying to move heat from the soldering iron down into the big metal pad that's on the bottom of this thing and down to the pad that's beneath this. All right, so that the solder will eventually melt, but it will only do this once it reaches down to that centralized pad. And this is kind of like the only access that I have to it at this temperature. Now, if I wanted for this to go a little bit faster, I could actually raise the temperature or get myself a larger soldering iron. I'm only applying a little bit of pressure with the small bent tip of this soldering iron right now. Whoa, geez, and the whole thing just flew right off when I went to go and make my light a little bit brighter, which now it's a little bit too bright. And gee willikers, gosh almighty, Christmas crackers is, but come here, you, come here, you. There we go. I don't have like really big tweezers that are meant for sort of handling a part of this caliber is what it is. So let's try that again with a little less silliness in it there. Come on, you. Hey, get back into place. Come on. Let's work with me here. All right, so now, again, I am applying some heat while this thing is just wiggling around all over the place, right? So I am applying heat with my soldering iron. I am applying force, which is going to be transferring conducting heat down from the soldering iron and all the way down to the pad beneath it. Now, I'm going to let this, you can see that the fluxing agent is starting to stir a little bit. You see how it's starting to kind of move around? That's because it's activating a little bit as well. And it's going to help underneath it. It's going to help the solder. See how the solder is starting to activate right now? See that? See that? Now I'm going to wait a little bit longer. You can kind of see on the edges of there, see that? Now at this point, all of the solder, or a majority of the solder underneath this transistor, has actually turned to liquid, right, underneath this thing. Now I'm going to let it sit there for just a little bit longer, right? It's starting to smoke at this point. The board is also getting very, very hot. Now I've removed the soldering iron. Part of this is turned back to a solid again. I'm going to let this guy go, all right? And several minutes later, now I have this thing attached to this board where it's, I mean, I can move this thing around. Now, let's try that same thing with my Weller soldering iron, which is, I think, well over the temperature of 610 degrees Fahrenheit is what this is. If I had to guess what temperature this is exactly at, I don't know if I'd really truly be able to tell you with this. All right, so I'm going to take a second transistor, and like just to show you, these transistors have a very large pad on the underside that I'm trying to solder this onto is right here. So I'm going to take this down right here, and with a lot more heat and this little pointed tip that I've got to it, I'm going to try to hold this guy into place. All right, so here he's held into place. Now I'm going to take this soldering iron here. Look at all the heat that just transferred to this thing. That's all melted already. Holy cow. You've got to be kidding me. I mean, it's smoking like crazy right now here. So I'm going to let it go. I'm going to let that go for right now. That happened really fast, which means I've actually just got a lot of heat applied to this, right? I've got a lot of heat applied to this. Oh, that didn't quite attach to it, did it? Did it just burn a whole bunch of stuff? It melted something on the bottom of it, but not enough, I guess, to melt the whole thing. I thought I saw something occur to her. That was just a little bit too fast. Let's watch it a little bit carefully on the inside of the on the camera there. I'm looking for any signs that this is starting to turn to liquid. That looks more like a liquid transition where the fluxing agent is heating up enough. There's the solder forming around the outside edge. I am applying a moderately good amount of force using my right hand with the soldering iron in it right now to try and get as much heat to flow down through that tip as possible. So now I'm going to remove the soldering iron, right? A whole lot of fumes are coming up and around me here. I'm going to place the soldering iron in its quote-unquote cradle, let go of the transistor. One of the things that helps, by the way, with doing any kind of soldering like this, getting a fan of some sort, something that can just kind of move some of the fumes around with. I myself actually like the smell of soldering iron fumes, but I know they're not very good for you. So I've gotten accustomed to looking at the smell of them. So now, not perfect alignment, but that's okay to it on there. You can tell though, if I do need to solder those final contacts onto here. So let me take the soldering iron in the Weller soldering iron in my right hand, and some solder wire into my left. Now, let me show you the right way on the right-hand side to do this, and the wrong way to do this on the left-hand side. I'm going to start with the wrong way to do this. The wrong way to do this is to just heat up the pad, apply a whole bunch of solder to the iron, and let it kind of go onto the pad. See that? That's a wrong way of doing it, right? The right way of doing this, is to actually heat the part up, right? Because watch this. I'm going to heat the part up. See this? The pad is actually ready to have solder applied to it. So I'm actually going to apply solder to the actual part itself, right? You see that? Solder just pretty much covered up and down the whole shoulder and toe, what they call like the shoulder and the toe, the whole thing, whereas it almost didn't touch any part of this. You have to get the part that you are trying to solder hot enough for solder to go to it, right? Looking at this part right there, I'm going to touch it and see how the solder just went attracted right up to it, right? You have to be able to do that. You have to be able to do that with a soldering iron. That happens really quickly with this Weller soldering iron tip. That actually happens surprisingly quickly. I'm actually going to disconnect it right now because, well, no, that's right, the 1206 resistors. Let me do those real quickly as well just to show you. Those actually would be placed in, for instance, R2. R2 is, I believe, a 1206 resistor. So I'm going to come down to that large pad there, apply a little bit of some solder to that, switch the soldering iron to my left hand, take a pair of tweezers, melt the solder at the pad, which connects the chip up to that spot there. Move them into place. I think this is a 5.23 kiloohm pad. My board is slightly burnt right now. Now, if I was a paying customer in the manufacturing industry, that's a huge no. Like, that's unacceptable. That's unacceptable in every single way that you would want to have a solder joint attached to this, without any doubt. I'm going to try to hit the other side up a little bit here, put some more solder onto the other side. That's much better, but that overall burnt brown look that's on there, that's usually just an indication that your soldering iron is just set too high. And with one of these Weller tips on there, if you're trying to do any kind of precision soldering to it, you can pretty much forget about it with something like that. So I'm going to disconnect this guy from here because I really don't want him attached to it. You know, and some places that like want to do soldering, they want you to work on chips that are, you know, less than 1/100th of an inch in their overall, that are in the millimeter scale, right? Some companies, that's just kind of what they want you to work on, right? That's their product, right? And they go to the store thinking, oh, it's just a soldering iron, you know, it's $30, it's cheap. No, it's way better using the correct tool for the job, for what this is. It's worth investing the extra money for something along these lines here, without a doubt, without a doubt. So now I'm going to take my Hako soldering station, all right, and I'm going to wait for it to get up to its temperature, which takes a little bit of a second because I'm letting it wake itself up from sleep, all right. And again, the right and the wrong way. The wrong way on the left-hand side, I'm only going to touch the pad, right, and I'm going to apply a whole bunch of solder onto that pad. Right, it may be tacked on like on the bottom of it, but it's not fully attached. And on the other one, I'm going to touch the leg. I'm going to touch the lead, of the part that I'm trying to solder on, and actually apply solder to just the. Wow, it's taken a while to heat up. That's because my temperature for this guy, oh, there it goes. See it? See it? It took a little bit longer for it to happen because my temperature for this one in particular is set so much lower. I don't know what the temperature of my Weller is, but it's pretty hot. Like it's pretty hot, right? This Hako station, I'm going to press on the left-hand side now. We're just going to watch that solder kind of gingerly flow itself over. Yeah, maybe a little bit of extra on there just to boot. And there you go. That's a well connected up solder joint. The other one to look up here is R2. R2 is what this is. All right, so. And now let's connect this up. So I'm going to take the soldering iron, apply some heat down to the pad. Tin the pad up with some solder. I'm using lead-based solder, by the way, the easier of the solders to basically work with. The lower temperature and easier to determine whether or not something has been connected up correctly to what this is. All right, so watch it kind of flow onto the resistor there. It's upside down, but that's okay. Still says 5,230 ohms. All right, connect this up again to the other side. And there you have it. No burn marks or anything like that. No brown burn marks on the side with it. So that's overall looking much better. So a soldering iron, that's pretty much what a soldering iron does. It takes heat from the tip and it heats up the thing that you are trying to melt solder to the point where the solder can actually bond up to it. And if you never get the part hot enough for the solder to bond up to that part, you get a cold solder joint, which is the solder joint. A cold solder joint is something that's doomed to fail. It's not a matter of if, it's a matter of when it will fail, right? It'll either fail mechanically, electrically, or in a number of other, potentially horrible ways to it is what it will fail like on there. So ultimately, in the end, you want to, if you're doing some more precise work to it where you do need some sort of temperature control, the soldering irons that are like these Hako stations, which transfer heat down to an easy to connect to tip, that heat gets transferred to the metal part that I want to solder to, so that when I touch the solid solder wire, the actual like solder wire that is made of the tin and lead, it melts on both on the part with the tip that's actually applying the heat to it. These other like cheaper soldering irons you can get from the store, I mean, like for basic stuff they're okay, but I mean, safety wise it's pretty bad. Like it scares me if you were to like leave a soldering iron on. I mean, worst bad things that can happen are someone could grab it on accident and get really hurt. Um, or you leave it set on like a piece of wood, a paper, or something like that, and you start a fire, stuff along those lines. Either way, you don't want that kind of stuff to happen at all. So that's, yow, even that guy, that's the ceramic little cup that this is in right now. That's hot. That is hot, is what that is. So, but anyway, hopefully you learned something new. Santi, that is for you, because he's actually specifically someone who was asking me about this recently. He probably wasn't aware that I was going to make a YouTube video for him. So, anyway, that hopefully that answers your question with that there. So, anyway, if you got any other questions, leave a comment down in the comment below if you want anything else done, and like if you like, dislike if you like, and we'll see you around on the next video. All right, see you later. Bye bye.